Good morning, students. Today in this session, we discuss about the theory of the Davangere University second semester Unit 4 topic theory of plane curves. In that one, asymptotes. What do you mean by asymptote? A line is called an asymptote to a curve if the perpendicular distance from the variable point P on the curve from the line tends to 0 as the point P tends to infinity. So this we call asymptote. There are two types of asymptotes, that is asymptotes parallel to coordinate axis, means parallel to the x-axis and y-axis, what we have shown, parallel to the x-axis and parallel to the y-axis, and the other one is oblique asymptotes, which are not parallel to the coordinate axis. Working rule to finding the asymptotes parallel to the coordinate axis for an algebraic curve f of x comma y is equal to 0. First one, to find the asymptotes parallel to x-axis for algebraic curve f of x comma y is equal to 0, equate the real line factors of the coefficient of the highest power of x to 0, and we solve. In the same way, to find the asymptotes parallel to y-axis for the algebraic curve f of x comma y is equal to 0, equate the real line factors of the coefficient of the highest power y to 0. Next, problems on finding the asymptotes parallel to the axis. Find the asymptotes parallel to the coordinate axis for the curve x square y square minus a square y x square is equal to a square y square. The given equation is x square y square minus a square and x square is equal to a square y square, right? So here in this we can take x square as common. We have x square into y square minus a square is equal to a square into y square. The coefficient of highest power of x is y square minus a square. So equate that to 0, y square minus a square is equal to 0. Then after solving, this is y is equal to plus or minus a. So are the asymptotes parallel to x-axis. In the similar way, they are asking the coordinate axis. That is, first we find out the asymptotes parallel to x-axis. Next, again rewriting the equation in the form of, okay, again I take this a square y square to left hand side and shift this minus a square x square to right hand side. What we have, x square y square minus a square y square is equal to a square x square. Taking y square is common, x square minus a square is equal to a square into x square. The coefficient of highest power of y is equating to 0. What we have, x square minus a square, that is equal to 0. Then x square is equal to a square, x is equal to plus or minus a. Are the asymptotes parallel to y-axis. Thus, the asymptotes parallel to the coordinate axis are x is equal to plus or minus a and y is equal to plus or minus a. Next, second one, the same, we have to find out the asymptotes. A square divided by x square plus b square divided by y square is equal to 1. The given equation can be written as, look here, a square into y square plus x square into b square, and the LCM is x square y square is comes to the right hand side into 1, x square y square, this shift to left hand side, what we have, minus x square y square is equal to 0. Coefficient of the highest power of x square in this is, here if we take x square is common, b square minus y square is the coefficients of highest power of x. That is the x. For x square, the coefficient is b square minus y square. Then solving this b square minus y square is equal to 0. What we have? Shift this to right hand side or one side. What we have? Y square is equal to b square. Y is equal to plus or minus b, or the asymptotes which are parallel to x-axis. Also, the given equation can be put in the form of, look here, taking y square is common, a square minus x square plus b square into x square is equal to 0. So, equating the coefficient of the highest power of y, it is here y square, the coefficient is a square minus x square to 0. What we have on solving this one is, put this to one side, positive side, x square is equal to a square. So x is equal to plus or minus e, are the asymptotes which are parallel to y-axis. Next, so here we have to find out the asymptotes parallel to x-axis. Next, we have to find out the second type of the asymptotes, that is the determination of oblique asymptotes. Working rule to find the oblique asymptotes for an algebraic curve of x comma y is equal to 0. Let f of x comma y is equal to 0 be the nth degree equation representing the given curve. First step, we have to write the given equation in the form of hn plus hn minus 1 plus hn minus 2 so on up to 0 equal to 0. Here h1 n that indicates the degrees. Okay, hi is the homogeneous expressions in x and y of degree I. I is nothing but it's a n minus 1 n minus 2 so on, right? Put x is equal to 1 and y is equal to m in the left side of the equation. So here the left side of this equation we put x is equal to 1 and y is equal to m. Then the equation takes the form phi n of m, right? That is of degree n, and plus phi n minus 1 of m plus phi n minus 2 of m plus so on equal to 0. Okay. Next, solve this phi n of m is equal to 0. We get the slopes of the asymptotes, and let m1 comma m2 so on be the repeated values of m. If the repeated values of slopes we get, then use this formula c is equal to minus phi n minus 1 of m divided by phi n dash of m for non-repeated values of m. Okay, and which gives the intercept c1 comma c2 so on. Then the asymptotes are y is equal to m1x plus c1 and y is equal to m2x plus c2 so on, etc. Okay, if phi n dash of m is equal to 0 and phi n minus 1 of m is not equal to 0, then there is no asymptotes for this value of m, right? And if phi n of m is equal to 0 as a repeated root twice, then using this formula we can find out the c value. C square divided by 2 into phi n double dash of m plus c phi n minus 1 dash of m, that is the first derivative of the function phi of the degree n minus 1, right? Plus phi n minus 2 of m is equal to 0. To find the corresponding value of c, in this case we solve this equation, and in this case we get the two parallel asymptotes. Note, the number of asymptotes cannot exceed than the degree of the equation to the curve. Right? It never exceeds the degree of the equation to the curve. Problems. Find all the asymptotes of the curve. Means it's a parallel and oblique asymptotes. Both should be, we have to find out. 4x square into y minus x plus y of y minus 2 into x minus y minus 4x minus 4y plus 7 is equal to 0. The given equation is just we write. So here just I grouped these terms which contains the degree 3 and this term which contains only the degree 2 and this term contain only 1, there is no 0. So look here, 4x square into y minus 4x cube. Okay, just I write this, and next y square into y square minus 2y we got, y square into x minus y, just multiply, y square into x means xy square minus y cube. Here these are the only terms we have the degree 3, and the remaining is minus 2y into x is minus 2xy, minus into minus plus 2y square, taking minus common 4x plus 4y plus 7 is equal to 0. Here there are no asymptotes parallel to the coordinate axis because the coefficient of highest power of x and y. Look here, the coefficient of highest power of x is here, x is there, x square is there, x cube. The coefficient is minus 4. That is a constant. If the power of the highest power of the coefficient of x is constant, then there is no asymptotes parallel to x-axis. In the same way, parallel to y-axis also, here coefficient of y cube is also a constant. So for both the coefficients are constant, therefore there is no the asymptotes which are parallel to x and y axis, coordinate axis. Next we have move on to find out the oblique asymptotes. To find out this, put x is equal to 1 and y is equal to m in this given equation. Here we have to substitute for this equation. Look here, y is equal to m minus m cube plus 1 into m square plus 4 into 1 into m minus 4. 1 cube is 1, 4 into 1 is 4, plus 2m square minus 2m minus 4 plus 4m plus 7 is equal to 0. So this is the given equation. Next, phi 3 of m, that is of degree 3. Okay, I write this thing. Okay, these are the terms which are having degree 3. Look at 3, 1 plus 2, 3, 2 plus 1, 3, 3. Totally, we have a 3 of degree 3. So, this is phi 3 of m, phi 2 of m, phi 1 of m, phi 0 of m. Okay, just I write. The slopes of the asymptotes are given by phi 3 of 0 is equal to m, right? Phi 3 of m is equal to 0. Phi 3 of m is minus m cube plus m square plus 4m minus 4 is equal to 0. On solving this, what we have, m is equal to 1 comma 2 comma minus 2. So these roots are real but they are distinct. Then to find, using the intercepts, c is equal to minus phi 2 of m divided by phi 3 dash of m. That is the highest power is phi 3. So highest degree. That is equal to minus of phi 2 of m is what? 2m square minus 2m. 2m square minus 2m divided by phi 3 dash of m. Phi 3 dash, that is the derivative, minus 3m square plus 2m plus 4. Minus 3m square plus 2m plus 4. Okay, this is c. When m is equal to 1, the roots are what? 1, 2, minus 2. 1, 2, minus 2. So 2 into 1 minus 2 into 1. 2 minus 2, 0. 0 by anything, 0. There are also non-zeros, this one. M is equal to 2. Here 2 2s are 4 minus, here 2 2s are 4, 4 2s are 8. Minus 4 divided by 2 2s are 4, 4 3s are 12. Plus 2 2s are 4 plus 4. 4 4 8. 12 minus 4, that is 8, 4 and minus 4. Minus 4 get cancelled 1. In the similar way, m is equal to minus 2. If m is equal to value, we get a 1 means it's a become minus 2. What we have? Minus of 2 into 2 square is 4, 4 2s are 8 plus 4 divided by minus 2 minus 12 plus next minus 4 plus 4 minus 12 divided by 16 minus 16 minus 12, it gets again 1. So hence the asymptotes are y is equal to m is 1 into x plus 0, that is x, 2x plus 1 minus 2x plus 1. So these are the asymptotes which are parallel to oblique asymptotes. Next, find all the asymptotes of the curve. Here 2x cube minus x square minus 2xy square plus y cube minus 4x square plus 8xy minus 4x plus 1 is equal to 0. To find the parallel asymptotes, just I write this asymptotes of the same degree. Look here, x cube is 2x cube, y cube, and this is also 3. This all are of the 3. Y cube minus 2xy square minus x square y plus 2x cube. Minus this one is minus 4x square plus 8xy is the second of degree 2, and minus 4x plus 1 is equal to 0. Then look here, the coefficient of highest power of x, here 2 constant, and coefficient of highest power of y is 1. So there is no asymptotes parallel to coordinate axis. Next we want to find out the oblique asymptotes. So y is put, x is equal to 1 and y is equal to m for this equation. What we have? M cube minus 2m square minus m plus 2. That is equal to, this is equal to, look here, that is again minus 4 into 1, 4 plus 8m minus 4 plus 1 is equal to 0. Then phi 3 of m is m cube minus 2m square minus m plus 2. Phi 2 of m is minus 4 plus 8m, right? Here minus 4x square plus 8m. If we take minus common, 4 minus 8m. Phi 1 of m is minus 4. Phi 0 of m is 1. Okay, we do not just simplify because the terms are required for to calculate the intercepts, right? Slopes of the asymptotes are given by, then the highest degree is phi 3 of m, right? The equation phi 3 of m is equal to 0. That is m cube minus 2m square minus m plus 2 is equal to 0. Or taking m square on both sides, we have m minus 2, and taking minus common m minus 2. Taking minus 2 is common both sides, we have m square minus 1 into m minus 2 is equal to 0. So m minus 1, m square minus 1 is m minus 1 into m plus 1 into m minus 2 is equal to 0. That is m is equal to 1 minus 1, 2. Next, to obtain the value of c, minus 2 minus phi 2 of m divided by phi 3 dash of m minus phi 2 of m is what we have, minus of 4 minus 8m or minus 4 plus 8m divided by phi 3 dash of m. Phi 3 dash 3m square minus 4m minus 1. Next, m is equal to 1. The roots are 1 minus 1, 2. 1 minus 1, 2. Apply m, minus of minus 4 plus 8 divided by 3 minus 4 minus 1. What we have? 8 minus 4 is 4. 4 again minus 4 divided by 3 minus 4 is minus 1 minus 2. So 2 2s are 4. M is equal to minus 1. What we have? Minus of minus 4 again minus 8, right? This one is m is minus 1, therefore this is a minus 8. Next, 3, this is 3 minus, here minus 1 is there, so therefore minus into minus is plus. Next, minus 1, minus 12 divided by, minus into minus plus 12 divided by 4 plus 3 is what we have, 7, 7 minus 6, right? And this one is positive, minus into minus is plus. So 6 2s, 6 1s is 6 2s are 12. Next, m is equal to 2. Minus of minus 4 into 8 2s are 16 divided by 2 2s are 4, 4 3s are 12, 12 minus 4 2s are 8 minus 1. What we have, 16 minus 14 is 12. 12 minus 12 divided by 12 minus 8 is 4, 4 minus 3, 4 minus 1 is 3, 3 4s are 12, the minus sign minus. So therefore the asymptotes are y is equal to 1 into x plus 2, that is x plus 2, minus x plus 2, 2x minus 4, right? These are the asymptotes, oblique asymptotes. Thank you.